Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from differentiability of functions, right? And here we'll examine the differentiability of this greatest integer function, that is f of x is equal to greatest integer of x minus 5 at x is equal to 5, right? So we'll see whether this function f of x is equal to greatest integer of x minus 5 is differentiable at x is equal to 5 or not, right? So let us start. So viewers, while proving the differentiability of any function, what we do, we find the right hand derivative, right? And the left hand derivative of the given function at the given point, right? And we see that whether the right hand derivative exists or not, and similarly the left hand derivative exists or not, and if they exist and finite and equal, then we can claim that the function is differentiable, right? So in this problem also we'll find the right hand derivative and the left hand derivative. So now the right hand derivative is defined by the limit, that is the limit h tends to 0 f of a plus h minus f of a divided by h, right? And here h is a positive quantity which lies between 0 and 1, and moreover h is infinitesimally very small, right? And here a is the given point, that is 5, right? So we can write limit h tends to 0 f of 5 plus h minus f of 5 divided by h, right? Now let us find out f of 5 plus h, right? So f of 5 plus h can be obtained from this function by replacing x by 5 plus h, right? So here we have 5 plus h minus 5, and here f of 5 is greatest integer of 5 minus 5, and here we have h, right? So uh, simplifying it, so we have limit h tends to 0, 5 and 5 get cancelled, so here we are left with greatest integer of h minus this is greatest integer of 0, and here we have h, right? So this is limit h tends to 0, and we know that greatest integer of 0 is 0, so this is simply greatest integer of h divided by h, right? So now we see that the value of h, it lies between 0 and 1, right? So h is very small, and it lies between 0 and 1. So by definition of greatest integer function, the greatest integer of h must be equal to 0, right? Because h lies between 0 and 1, right? So here this term becomes 0, so the entire limit is 0, right? So the right hand derivative of this function at x is equal to 5 is equal to 0, right? Now let us find out the left hand derivative, right? So the left hand derivative is defined by this limit, that is limit h tends to 0 f of a minus h minus f of a divided by minus h, right? And again a is 5, right? So this is limit h tends to 0 f of a minus h. So a is 5, so we have 5 minus h, and here we have f of 5, and this is minus h, right? So this is limit h tends to 0 f of 5 minus h. So replacing x by 5 minus h, we'll get here 5 minus h minus 5, and here we have greatest integer of 5 minus 5, right? And here in the denominator we have minus h. So now simplifying, we have limit h tends to 0, here 5 and minus 5 get cancelled, so we are left with greatest integer of minus h, and here we have greatest integer of 0. This is minus h, right? And this is limit h tends to 0, greatest integer of minus h divided by minus h, because greatest integer of 0 is 0, right? So now our aim is to find out the value of this limit, right? And we see that here we have greatest integer of minus h, right? So we have to take care of this term, that is greatest integer of minus h. So now see here, we see that h lies between 0 and 1. Now multiplying throughout by minus 1, because here we want to get minus h, right? So multiplying throughout by minus 1, here we have 0, the direction of the inequality get reversed, and here we have minus 1, minus h, and 0, right? So this is the inequality, right? So minus h lies between minus 1 and 0. So this is minus 1 and this is 0, right? So h lies between 0 and 1, but minus h lies between minus 1 and 0, right? So from the definition of greatest integer function, the value of greatest integer of minus h must be equal to minus 1, right? So now this limit, that is the left hand derivative, is limit h tends to 0, and here we have, for greatest integer of minus h we have minus 1, and in the denominator we have minus h. So minus and minus get cancelled, so we are left with limit h tends to 0, 1 over h, right? So now viewers, we can see that this limit obviously tends to infinity, right? Because when h tends to 0, 1 over h tends to infinity. So we can see that the left hand derivative, it does not exist, right? So the left hand derivative is not defined here. So we can see that the right hand derivative is 0, and it is finite, but the left hand derivative does not exist, right? Or it is not defined. So we can safely claim that both the derivatives, that is the right hand derivative and left hand derivative, are not equal, right? Although the right hand derivative, it exists and it is finite, right? But the left hand derivative is not defined. So we can safely claim that this function, that is the greatest integer function, this function is not differentiable at x is equal to 5, right?